So now I want to try to determine if this quadrilateral is a parallelogram. So I have two examples drawn. So first thing you need to decide is, do you have enough information? Then if you have enough information, is this a parallelogram? So the one on the left. First question, is there enough information to determine if this is a quadrilateral? And the answer is no, because we would need to know, since we know nothing about the angles, we would have to know what the length of this last side is, and we don't. If this were indeed 8, then it would be a quadrilateral. But we don't know what it is, so there's not enough information. And we have no way of figuring it out. Okay, the one on the right. Is there enough information for us to determine if it's a quadrilateral? I mean, if it's a polygon, sorry. And the answer is yes. There is enough information. We have to do some calculations to figure it out. Remembering that the sum of all of the interior angles of a quadrilateral is 360 degrees, I can use that information to find out what the last angle is. And the last angle is 105. It's the same as the angle opposite. So yes, there's enough information, and yes, it's a parallelogram. For the following parallelogram, or I should say quadrilateral, with diagonals 2y minus 7, y plus 2. This side is y and this side is 3x. For what value of x will this be a parallelogram? So what do we have and what do we know? I can't read this, sorry. Y plus 2. We have the diagonals, and that's all we have. We don't know anything about the sides. We don't know anything about the angles. So we do know the theorem that tells us that if these diagonals bisect each other, then the quadrilateral is a parallelogram. So let's set up our equations. We have 3x equals y, and we have 2y minus 7 equals y plus 2. Okay, so I can start here because I just have one unknown. I'm going to add 7 and subtract y to both sides, and I end up with y equals 9. I take this 9, plug it in up here. I have 3x equals 9, therefore x equals 3. And that's actually what we're looking for. Can't lose sight of what we're looking for. We're looking for x. We're not looking for y. Were this a multiple choice question, I can guarantee that 9 would be one of the choices and you would be wrong. I just have a few more examples. One using algebra and the other is a proof. Okay, so first example. Okay, I have a quadrilateral. It says that this is congruent to this, and I need to find x such that this is a parallelogram. So if this were a parallelogram, and this is the diagonal, and this is the diagonal, these two already are congruent, so we can, to solve this, assume that these also are congruent, and we end up with x equals 5. So here I have a quadrilateral, and this angle is x. It is by markings congruent to the angle across from it. This angle is y, and it is by markings congruent to the angle across from it. So I actually want to prove that quadrilateral ABCD is a parallelogram. Two-column proof, statements and reasons. My first statement is that x plus y plus x plus y equals 360. And the reason I can make that statement is that the sum of the measures of a quadrilateral is 360. Next, I'm going to rewrite this. Does anybody know what property allows me to do this? I actually skipped a step here. I combined these. When I combined them, I had 2x plus 2y equals 360. So what property allows me to do this? It's the distributive property. What allowed me to go from step 2 to 3? The division property. Let's see. 4 says, how about angle A and angle B are supplementary? And angle A and angle D are supplementary. It's the definition of supplementary. If we look back at step 3, what did it say? It said x plus y equals 180. X plus y equals 180. X plus y equals 180. That's the definition of supplementary, when two angles add up to 180. Next, I'm going to state that AD is parallel to BC, and AB is parallel to DC. And I can state this because if same side interior angles are supplementary, and the lines are parallel. And ABCD is a parallelogram because of the definition of parallelogram, which says that you have two pairs of parallel lines.